Hello and welcome. In this video, we'll walk you through everything you need to know about ISO 9241 Guideline for Ergonomics of Human System Interaction, in simple, clear terms. In a human-centered design process, each team has a clearly defined responsibility that must be followed. The UX design team must design user-centered interfaces based on user needs, tasks, and usability principles. They have to ensure that the experience is intuitive, efficient, and aligned with real user behavior. The software team must implement the interface logic while ensuring usability, performance, and accessibility requirements are met. They have to translate design into a functional and reliable system. The team lead must oversee the entire human-centered design process, coordinate between teams, and ensure that all activities comply with ISO standards and project requirements. Following ISO standards is essential to ensure better product quality and user experience. It improves overall user experience by making systems more intuitive and easy to use. It reduces errors and user frustration by ensuring designs are tested and validated. It also increases productivity as users can complete tasks faster and more efficiently. ISO standards help ensure legal and accessibility compliance, making products usable for a wider range of users. Most importantly, they provide a structured human-centered design framework, ensuring that user needs are always at the core of the development process. ISO 9241 defines a set of standards that guide human-centered design and usability in systems. Previously, we had covered ISO 924111 defines usability through measurable factors like effectiveness, efficiency, and satisfaction. ISO 9241-110 covers dialogue principles, guiding how users interact with systems in a clear and intuitive way. Today, we will cover ISO 9241-112 focuses on information presentation, ensuring content is structured and easy to understand. ISO 9241-171 addresses accessibility in software, making systems usable for people with diverse abilities. Together, these standards ensure systems are usable, accessible, and user-focused. Next, we'll walk through ISO 9241-112, which focuses on information presentation and user interfaces. It ensures information is displayed clearly, consistently, and in a way that supports easy understanding and efficient user interaction. ISO 9241-112 information presentation focuses on how information is structured and displayed for user understanding. It includes clarity and comprehensibility, discriminability, conciseness and relevance, consistency, detectability and feedback, legibility and readability, and accessibility and inclusivity. These ensure users can quickly perceive, process, and act on information without confusion. Clarity and comprehensibility must ensure that users can easily understand information without confusion. The UX team must design content that is simple, clear, and easy to understand. Language must remain consistent across the system, and readability must be maintained at a grade 6 to 8 level. Grade 6-8 readability means content must be simple enough for a student in grade 6 to 8 to easily understand using clear words and short sentences. For example, instead of using complex terms, simple instructions like enter your address improve understanding. The software team must ensure correct data formatting based on user location, such as date, time, and currency formats. User misunderstanding must not lead to high error rates, and error rates for routine tasks must remain below 5% to ensure clarity in interaction. Discriminability must ensure that important information stands out clearly from less important content. The UX team must design interfaces where key information is visually prominent. Contrast ratios must meet WCAG 2.1 AA standards with at least 4.5 to 1 for normal text and 3 to 1 for large text. For example, primary buttons or alerts should be highlighted using strong contrast so users can easily identify them. The software team must maintain visual consistency across different devices and screen sizes. Critical alerts must be visually distinct and noticeable, such as using clear color changes, icons, or emphasis to ensure users do not miss important information. Let's look at an example in the next slide. Conciseness and relevance must ensure that users see only the necessary information without overload. The UX team must present only essential information and avoid increasing cognitive load. Content must be clear and focused, following principles like Miller's Law, where users can handle around 5 to 9 items at a time. For example, a menu should not display too many options at once, making it easier for users to choose quickly. We will discuss about Miller's Law, Hick's Law, and Fitts' Law in the next slide. Miller's Law states that users can effectively retain only about 7 plus or minus 2 items in their working memory at a time. In UX design, information should therefore be grouped into smaller, manageable chunks to reduce cognitive load. This helps users process information more easily and improves overall usability and decision-making. There are a few examples that will help us understand better. On the left, too many navigation options increase cognitive load and make it difficult for users to quickly find important actions. On the right, related options are grouped and prioritized, making the interface easier to scan, understand, and navigate. On the left, presenting all form fields on a single page overwhelms users and increases cognitive load and errors. On the right, breaking the form into smaller steps helps users focus on one task at a time, improving clarity and completion rate. On the left, too much ungrouped information makes the dashboard cluttered and difficult to scan or understand quickly. On the right, related data is organized into clear cards and sections, helping users focus, navigate, and make decisions more efficiently. Next, we will discuss about Hick's Law states that the time required to make a decision increases with the number and complexity of choices available. In UX design, too many options can overwhelm users and slow down decision-making. By simplifying choices and prioritizing important actions, interfaces become faster, clearer, and easier to use. There are a few examples that will help us understand better. On the left, too many navigation options increase decision time and make it difficult for users to identify important actions quickly. On the right, prioritized and limited options simplify decision-making, helping users navigate faster and complete tasks more efficiently. On the left, displaying too many filters at once overwhelms users and increases cognitive load during product selection. On the right, filters are grouped and progressively disclosed, helping users focus on relevant options and make decisions more easily. On the left, too many pricing options make comparison difficult and increase user confusion during decision-making. On the right, a few clear and well-structured plans help users compare quickly, decide faster, and choose with confidence. Next, we will discuss about Fitts' Law states that the time required to interact with a target depends on its size and distance. Smaller or hard-to-reach targets take longer to interact with and increase the chances of user error. In UX design, important actions should be large, clearly visible, and easy to access for faster interaction. There are a few examples that will help us understand better. On the left, the small CTA button is difficult to notice and tap, increasing user effort and interaction time. On the right, the larger and more prominent CTA button is easier to access, helping users complete actions faster and more accurately. On the left, important actions are placed outside the natural thumb reach area, making interactions slower and less comfortable. On the right, frequently used actions are positioned within easy thumb reach, improving speed, accessibility, and one-handed usability. On the left, small and closely placed icons make interactions difficult and increase the chances of accidental taps. On the right, larger buttons with proper spacing improve accuracy, usability, and overall interaction speed. The system is designed with a scalable architecture that can efficiently support personalization features for different users. Even with personalized content and settings enabled, the application performance remains stable and responsive. This ensures a smooth, reliable, and consistent user experience as the system grows and adapts to user needs. Consistency must ensure that users experience the same patterns, layouts, and behaviors across the entire system. The UX team must present similar information in the same format across all screens. Typography, color codes, icons, and layout structures must be standardized. For example, if a primary button is blue on one screen, it must remain the same across the entire product. The software team must implement shared design systems and component libraries to maintain consistency in development. Inconsistent interfaces can increase error rates, so routine task error rates must remain below 5% to ensure a smooth and predictable user experience. In the next slide, we have different screens with same visual consistency. Detectability and feedback must ensure that users immediately understand what is happening in the system after every action. The UX team must make all important system changes clearly visible. Feedback must appear within 1 second after a user action. If a response takes longer than 1 second, loading indicators must be shown. For example, when a user clicks Submit, they must instantly see a confirmation or a loading state. The software team must support real-time updates, notifications, and system status. Delayed or missing feedback can increase user frustration and abandonment rates, so system responses must be fast, accurate, and consistent. Legibility and readability must ensure that text is clear, easy to read, and accessible across all devices and environments. The UX team must design text that remains readable in different conditions, including various screen sizes and lighting environments. Body text must be at least 16 pixels for digital interfaces, and line spacing must support easy scanning. For example, well-spaced text helps users quickly read and understand content without strain. The software team must implement responsive layouts to ensure text adapts to different screen sizes. Accessibility must comply with WCAG 2.1 AA standards, ensuring proper text resizing and compatibility with screen readers for all users. Accessibility and inclusivity must ensure that the system can be used effectively by people with diverse abilities. The UX team must design information in a way that accommodates users with disabilities. Alternative text must be provided for images, and captions must be included for multimedia content. Interactive elements must also be accessible through the keyboard. For example, a user should be able to navigate and use all features without relying on a mouse. The software team must implement ARIA roles and semantic HTML to support assistive technologies like screen readers. Semantic HTML and ARIA roles must ensure that the system can be correctly understood by assistive technologies like screen readers. For example, instead of using a generic open div tag, developers must use proper tags like open button tag and add ARIA labels so a screen reader can announce Submit button clearly to the user. The system must also maintain high reliability, with uptime above 99.5%, ensuring continuous access for all users. Designed for the people with disabilities. Examples for bad and good UI design. ARIA, which stands for Accessible Rich Internet Applications, is used to make software interfaces more accessible for users with disabilities. ARIA roles help screen readers identify the purpose of UI components such as buttons, dialogues, tabs, and navigation menus. It provides additional semantic information when standard HTML elements are not sufficient. This ensures users can understand, navigate, and interact with digital interfaces more effectively. Overall, ARIA plays a critical role in creating inclusive and accessibility-compliant software systems. Next, we'll walk through ISO 9241-171, which focuses on accessibility in software systems. It ensures digital products are designed to be accessible, inclusive, and usable for people with different abilities and accessibility needs.
ISO 9241-171. Accessibility in software defines requirements to make systems usable for people of all abilities. It covers perceivable information, operable interface, understandable content and navigation, robust compatibility, visual accessibility, motor and interaction accessibility, and testing and compliance. This ensures inclusive design is built into both UX and development. Perceivable information must ensure that all users can see, hear, or understand content regardless of their abilities. The UX team must design content that is accessible to all users. Information must be clearly visible, and text alternatives such as alt text must be provided for images and non-text content. Contrast ratios must meet WCAG 2.1 AA standards to ensure readability. For example, an image must include a description so screen reader users can understand it. The software team must ensure technical accessibility by supporting screen readers through semantic HTML and ARIA roles. Text must be resizable up to 200% without losing content or functionality, ensuring users can adjust the interface based on their needs. An operable interface must ensure that all users can interact with the system regardless of how they input actions. The UX team must design interfaces that can be operated using different input methods such as mouse, keyboard, or touch. All interactive elements must be reachable using the tab key. For example, a user should be able to navigate through a form entirely using the keyboard. The software team must ensure that focus indicators are clearly visible and consistent across the interface. Time-based interactions must allow users to extend or remove time limits. For example, if a session is about to expire, the user must be given an option to continue instead of being logged out suddenly. Understandable content and navigation must ensure that users can easily predict and follow the system without confusion. The UX team must design content and navigation that are clear, simple, and predictable. Layouts must remain consistent across screens and must avoid sudden changes in context. Form instructions and error messages must be clear and easy to understand. For example, a user filling a form should immediately know what is required and how to fix errors. The software team must implement proper input validation with clear and descriptive error messages. Routine task error rates must remain below 5%, ensuring that users can complete tasks smoothly without confusion or repeated mistakes. Robust compatibility must ensure that the system works reliably across different devices, browsers, and assistive technologies. The UX team must avoid design elements that break assistive interpretation. For example, using non-standard components without proper labels can make it difficult for screen readers to understand content. The software team must ensure compatibility with assistive technologies such as screen readers. Code must follow structured markup standards like semantic HTML to ensure proper interpretation.
Accessibility must also be tested across multiple browsers and devices to guarantee a consistent and reliable user experience. Visual accessibility must ensure that content is readable and usable for all users, including those with visual or cognitive challenges. The UX team must design text with a minimum size of 16 pixels for body content to ensure readability. Proper line spacing and paragraph spacing must be used to support users with dyslexia. Color must not be the only way to convey meaning. For example, errors should be indicated with icons or text, not just red color. The software team must ensure that layouts do not break when zoomed up to 200%. Animations must include pause or stop options to prevent discomfort, especially for users sensitive to motion. The system must maintain a stable and accessible experience across all visual settings. Motor and interaction accessibility must ensure that users can easily interact with the system regardless of physical ability. The UX team must design clickable and touch targets that are at least 44 by 44 pixels to ensure easy interaction. Adequate spacing must be maintained between interactive elements to prevent accidental clicks. For example, buttons should not be placed too close to each other. The software team must support alternative input devices such as keyboards or assistive tools. Drag and drop interactions must also provide keyboard alternatives. Critical actions must allow undo or corrections so users can easily fix mistakes without frustration. Interactive elements in a form must have sufficient spacing to improve readability and ease of interaction. Poor spacing makes interfaces feel cluttered and increases user errors, while proper padding creates a cleaner, more accessible, and user-friendly experience. Testing and compliance must ensure that accessibility is validated and maintained throughout the product lifecycle. The UX team must include accessibility testing as a core part of the development process. Manual testing must be conducted for proper validation, and at least 5 to 8 users must be involved in formative testing, including users with disabilities whenever possible. For example, testing with screen reader users helps identify real accessibility issues. The software team must maintain proper documentation for accessibility compliance and audits. System performance must remain reliable, with uptime above 99.5%, ensuring continuous accessibility and availability for all users. Accessibility is not the responsibility of a single team. It is a shared commitment between UX and software development. It must be embedded from the beginning, designed with clarity and inclusivity, and implemented with precision using proper standards and validation. The call to action is clear. Design with intent, build with responsibility, and ensure accessibility is the default across every stage. Thank you.